Good morning friends. Today we will discuss about some important topics of chapter number 5 surface chemistry, which would be frequently asked in examination in past year. There are some points that I choose. First one is the Freundlich adsorption isotherm. So we will discuss in detail through its points. So as you learn Freundlich adsorption isotherm, the law is the adsorption of a gaseous adsorbate on a surface of solid adsorbent is directly proportional to adsorbed gas. So we will write a law the adsorption of gaseous adsorbate, the adsorption of gaseous adsorbate on the surface of solid adsorbent is directly proportional to pressure of adsorbed gas. So this is the law of Freundlich adsorption isotherm. So we can represent this law in form of a formula that X by M is directly proportional to P raised to 1 upon N. I will give this is equation number 1. Now where M I will mention over here, where M is a mass of solid adsorbent and X is a mass of gaseous adsorbate. So these are the terms which indicate what you mean by X by M. Here in X, instead of mass you can choose pressure of adsorbate. In various books you can find that instead of mass the word pressure is also given. So different reference book having different word over here. So here X by M is called as a adsorption, which is directly proportional to P, means pressure of that adsorbate gas. Now we can simplify above equation in term of constant K, Kp raised to 1 by N. This is equation number 2. So in equation number 2 we can say that here K and N both are constant. So I will write here K and N both are constant, which are depend on temperature. So they are temperature dependent quantity. Here we will find that N, the value of N is always greater than 1. It indicate what? That if N greater than 1, then X by M does not suddenly increase with increase in temperature. So we can learn from here the value of N always greater than 1. So if N greater than 1, then X by M does not suddenly increase with increase in pressure, even though they have direct relation. Now taking a log of equation number 2 on both sides. So we will mention taking log of equation number 2 on both sides. So equation number 2, taking log, so we get log x by m is equals to log k plus 1 upon n log p. This is equation number 3. So this is the logarithm of equation number 2. Now from this graph we can assume that this reaction is quite similar, this equation is quite similar with y is equal to mx plus c. So I will write one statement over here. Above equation 3 is similar with y is equals to mx plus c. So if this equation is similar to y is equal to mx plus c, then we can plot a graph of log x by m against log p. So now we can plot the graph. We can plot the graph of log x by m against log p. So which type of graph that we observed? So it is quite similar with y is equal to mx plus c, means we get a straight graph or straight line in form of this is the x-axis, there is a y-axis. Now on this axis I will indicate log x by m, other axis log p. So graph is a straight line. Here we get intercept, so I will write intercept. Here we get slope, so I will write slope. Now from the equation number 3, what is the intercept and what is the slope? So equation 3 we can say that log k is our intercept, so I will write log k. From equation 3 we can say that 1 by n is our slope, so I will write 1 upon n is a slope. So this is the graph which indicate a straight line which follow y is equal to mx plus c equation. The value of 1 by n should be range from 0 to 1. This is the important statement, so I will mention over here. The value of 1 by n range from 0 to 1. So you have to remember that value of 1 by n range from 0 to 1. Now there are some limitations of a Freundlich adsorption isotherm. So we will write some limitations. So here we will discuss about limitations. Limitation number 1, that a Freundlich adsorption isotherm, it is applicable to only low pressure. So I will write over here, it is applicable to only low pressure. At high pressure it shows deviation. At high pressure it shows deviation. This is the first limitation of Freundlich adsorption isotherm. Now we will discuss about a second limitation also that here we are mentioned that K and N both are constant which are temperature dependent. So it is second limitation of Freundlich adsorption isotherm. So we will write that number 2, K and N both are temperature dependent. So if there is a change in a value of temperature, the value of K and N also undergo change. So this is the limitation number 2. This is second limitation. Now limitation number 3, that this isotherm is empirical, means there is no theoretical evidence which are present. So number 3 limitation, this isotherm is empirical. Empirical means experimental only. There is no theoretical evidence. So this is its limitation number 3. Limitation number 4 and its last limitation, that we know that 1 by n, it having two type of values. If 1 by n is equals to 0, then x by m becomes constant, means adsorption is independent from pressure. But if 1 by n is equal to 1, then x by m is equals to Kp. Means what? Means adsorption is depend on pressure. So these are the limitations of a Freundlich adsorption isotherm. So we can clearly say that this is the theorem. Up to this is the theory of Freundlich adsorption isotherm, and these are the limitations in a sequence number 1, 2, 3 and 4. So this theory should be frequently asked in 3 or 4 mark in examination. Next point is difference between lyophilic sol and a lyophobic sol, which is also important, should be asked in 3 mark. So what do you mean by lyophilic sol? So we can say that philic means to attract or loving, and phobic means to hate or repel. So according to these words, we can write that first point, they are liquid loving. So lyophilic sols are liquid loving. On the other hand, they are liquid hating. Now second difference, that their examples. So which sols are called as a lyophilic sol? So I will mention sol of gum, starch, gelatin and rubber are examples of such type of soil. On the other hand, soil of metals and their sulfides are examples of such a type of soil. Number 3 is about dispersion medium and dispersion phase. So here dispersion medium is separate from disperse phase. So we will write that here dispersion medium is separated from disperse phase. On the other hand, dispersion medium does not separated from disperse phase. So these are the keyword. It should be separated, here it should not separate. Now difference number 4, that about reversible nature. So it is reversible soil. On the other hand, it is irreversible soil. So point number 4 is about their reversibility. Point number 5 is these soils are stable and does not require stabilizing agent. So I will write into two different points. They are stable. On the other hand, they are not stable. So due to its stable nature, they do not require stabilizing agent. So I will write do not require stabilizing agent. But on the other hand, due to its not stable nature, it require stabilizing agent. So I will write it requires stabilizing agent. So this is all about difference between lyophilic and a lyophobic soil. So weekly we will revise that left side lyophilic soil and other side lyophobic soil. Lyophilic, philic means attracting or loving, so they are liquid loving. On the other hand, phobic means hating or repelling, so they are liquid hating. Examples are salts of gum, starch, gelatin, rubber, which are the examples of such type of salt. On the other hand, metal and their sulfides are example of such a type of soil. Here if we will discuss about dispersing medium and dispersion phase, that in this case dispersion medium is easily separate from the dispersed phase. So here simply you can follow evaporation, by which you can separate dispersed phase. On the other hand, dispersion medium does not separate from the dispersed phase. Fourth point is about their reversible nature, that lyophilic soil, it is reversible soil. The hint of point number 4 is given over here. Why it is reversible? Because dispersion medium is separate from dispersed phase, but if you want to mix again, then you can easily mix. It is irreversible. Number 5, they are very stable in nature, but on the other hand lyophobic soil, they are not stable. So due to its stable nature of lyophilic salt, they do not require stabilizing agent, itself be stable. But due to not stable nature, it require stabilizing agent.